This is A-level Computer Science 9618 paper 4. This is our chapter OOP, and we're going to start right from the beginning. We're going to start where we left off. We in the previous video we discussed about inheritance and polymorphism. So right now we're going to understand about what is the types of inheritance, like aggregation and composition. Then we're going to understand about interface, abstract exception handling, and file processing, and then this whole OOP will be covered. Okay, so let's begin. So first of all, let's start from composition. There you go. So two types of relationship. Inheritance is a relationship. Okay, association, which means aggregation, composition has a relationship. Aggregation and composition, the difference between these two is in aggregation. In aggregation, the entities are independent to each other, which means, for example, for now let me just tell you that that entities are independent on each other, and in composition both entities are dependent on each other. So let's start from aggregation. This aggregation, okay. For example, we have two classes. One class is public class address, and another class is public class employee. Every employee has an address to live in. Okay, an address. So it's more like has a relationship. Every employee has an address. Okay, has a home address. So we created this class and having these attributes, and we got a constructor, okay, the whole thing is done. This is our class. It's we just create the class and having these attributes. Okay, another thing is that we just created employee class. Okay, and inside this class we have attributes, and we have this we have created an you can say a user defined data type of address. Okay, so address is a class name, and then we just created this. We are creating the object in such a way that we are connecting these these two entities in such a way that it is independent, that these two classes are independent to one another. How is it happening? Look here. Okay, so first of all we created this. Okay, and then this is our constructor, and what we did, we just passed this. Okay, and this is equal to this. Now it becomes an object. Actually this was an object, but it's null completely. It doesn't have it, it's completely null. If you try to print this, then it will give null. Okay, because it's not storing any memory. Okay, it's not storing any memory, and because we didn't use the new keyword, and also we didn't use the constructor, that's why it's completely null. But if we try to pass this after creating it in the main method, like address1 is equal to new address, we have created an object right here, and then what we have done, we just pass this into the employee constructor. After passing this, the memory will be saved here. Okay, we just initialize the value, you can say the memory inside this, and so it becomes an object, and now we can just use this like that. So we didn't create an object inside here, we just passed this, and then it's storing a memory, okay, and it just stored in this variable, this user defined variable. Okay, so and then you can say that it becomes an object like that. So yeah, this is aggregation. But what happens in composition is that you try to create an after you just try to create an object right here. Create an object, and then you can use it. In there we don't create any object, we just pass the user define, and then containing a memory, and then it get passed, and it's it get initialized. But in here we just try to create an object. So supposing if I delete this class, then this will automatically be deleted. That's why we can say that the two entities are dependent to one another. This will, if the parent class is destroyed, the child class will also be destroyed. If this class is destroyed, if the employee is destroyed, the address will also be destroyed. Okay, so that's why we can say that these two entities are dependent to one another, while in this scenario the address and employee are completely separate. Okay, so even if we destroy the employee class, the address object will still remain, because we have created this in here. They are independent, they are not dependent to one another, which means that one entity is not dependent on one entity is not dependent on the existence of another entity. Okay, if one entity is dead, the other can live on its own. That's why they are independent to one another. So that's the difference between aggregation and composition. Okay, so let's move on. Now we have abstract and interface. Let's start with abstract. What is an abstract? Abstract is a generalized class. It means it just gives you an idea that what should be implemented. For example, you have this class abstract class A. Or let me just, here you go. This is my abstract class. Okay, okay. Whenever we create an abstract class, we will have to use this keyword. This keyword is very important in order to create an abstract class. Okay, after creating this abstract class, we can have methods, abstract methods, and the meaning of abstract method means that it is empty. You just give a signature for it to be implemented. You just give a signature. To be override in order to in abstract class you try to override these methods, which are nothing but signature. It's just giving a signature that yes, this is a class, and you should have these kind of class, that it should be implemented in your code. Okay, so this is a signature, actually just a signature. So you can see here that I just override this. Okay, I have just override this. For example, if I try to remove this, let me just, if I remove this, okay, now it's giving me an error. It's saying that you need to add unimplemented method, you need to implement this. So I'm going to implement this, F2, and then click here, and then you got this code generated. Okay, overriding this method. So abstract class is nothing more than just it's these methods are just signatures, and they want you to override these methods. Okay, then we have this int age. Okay, attributes are static in nature in the abstract class. They are static in nature. These are static attributes. Static. Okay. We can have signature methods, and we can also have normal methods, which are completely, complete methods. So you can say that abstract class are incomplete class. You can say they are incomplete class because they have a mixture of complete methods and signature methods. And also, every abstract class must have a constructor in order to work. So every abstract class must have a constructor. Because if I run this, and you can see it for yourself that the abstract class constructor will run first. Let me show you. If I just run this, okay, so there is an error. It's okay, it's nothing. Let's proceed. I am an abstract constructor. Walking in the park, which is because I have just uh okay, I haven't done it. Walking the because I just called this. Okay, I have called the method of this abstract class. And also, if I try to write down something in here, let me write it down. I am doing something. And if I just run this, I am doing something walking in the park. Okay, so this is abstract class. So they are generalized class. Common cannot make objects. Yes, you cannot make objects from the abstract class directly. Implementation is hidden, just hiding the implementation. Only functionalities is defined, that what should be the functionality of this particular class. Okay, connected to method overriding, polymorphism, which we discussed yesterday. Constructor, abstract methods, non-abstract methods contains inside abstract class, can have static and final functions, null implementation, so that abstract method destroyed. Okay, abstraction can be achieved using interface and abstract class. Abstract class is an incomplete class. A class which has at least one abstract method needs to be declared as an abstract class. Okay, can inherit any other abstract class using extend keyword. Abstract class can inherit any extend class. Okay, abstraction in Java is a technique by which we can hide the data that is not required by user. It hides all the unwanted data so that user can work only with the required class. Can make object in concrete class, but in abstract class we cannot do anything like that. Abstract method cannot be declared private. Abstraction hides the implementation details from user whereas encapsulation wrap uh, bind data and code into a single unit. That it's just telling the difference between abstraction and encapsulation. If the abstract class doesn't have a constructor, a class that extends that abstract class will not get compiled, so constructor is necessary. Okay, constructor is necessary. Okay, so this is abstract. Interface is itself is abstract. It's similar to abstract class, except that interface doesn't have a constructor and it doesn't have normal methods. It will only have abstract methods. Okay, it will only have abstract methods, actual name, and okay. uh, all method must be implemented. You're having an interface class, you know, you having so many abstract methods. After implementing this in abstract, you try to extend, like do in order to inheritance. But an interface class, whenever you need to inherit the interface class, you will use the keyword implement, and after doing so you will have to implement all of these signature methods, all of them. That's the difference between abstract class and otherwise. Okay, the method is an interface are public abstract by default. By default they are public abstract. A class can implement more than one interface at a time. Okay, An interface can inherit any other interface using the extend keyword. Collection of abstract methods only. Data must be static and final and public. Talking about the attributes, okay, must be static, final and public. If putting final in method, then it will not be override. Can implement more than one interface. Only abstract and public modifiers are allowed for method in interface. Interface cannot have a constructor because a constructor cannot be called using super keyword with hierarchy. Okay, let's begin. We discuss about the abstract. Now let's discuss about interface. Okay, so right now I'm going to create some signature methods like abstract. Let's say I'm writing down the method public void do and die or something like that. Do and die. And there you go, I've just created this signature, but by default it is public and abstract. So let me just write it down. Abstract by default. Okay, why it's giving an error? Okay, I can have so many multiple signature methods. Okay, giving the functionality only, nothing more, nothing less. Do and eat. Okay, I cannot have a constructor. I cannot have normal methods. I can have attributes like int int color. Okay, string. It's giving an error saying initialize final. Okay, so it's static and final. So let me just give something like blue. Now the error is gone. Let's make another interface. Okay, color 1, let's say it's green. Die 1, eat 1. Okay, it's different. Now interface E extends C and D. Okay, extend again D. Or let me just try again. Okay, so let me let me do extend, let me inherit extend D comma, if I put C. Okay, it extend D and C. Wow, that is amazing. So you can do something like that. But if I create a normal class like class human and now, okay, let me show you something else. What I can do is I can make another class animal. Okay, now let me show you how multiple inheritance works. I will extend animal and implement C, and there you go. Okay, I add unimplemented methods. Okay, right now I've just done multiple inheritance, so congratulations, this is how you do multiple inheritance. And secondly, when you do implement, then you need to implement, you need to implement override all these methods, because that's what interface is all about. You click and you just There you go. Do and die, do and eat. This is interface. Okay. So the only reason why why I decided to teach you guys about abstract and interface, because yeah, at some point it might be useful to know this knowledge, and secondly, this word is being used in file processing. That's why I have to teach you guys. Okay, so this is interface. The difference between abstract and interface is abstract interface doesn't have a constructor, and it cannot have normal methods, while in abstract it's completely different story. Okay, so this is how it happens. Let's move on. Shortcut keys for Eclipse. Sys out controls page, you will give a complete system.out.println. Okay, for run, press F11, you can run directly. Main, if you want to create a main, then control plus space. If you want to have get a setup, which I have done this in my first video of OOP, I can do, we can do all of these things. It's a complete shortcut, might help you in the exam, hopefully. If you want to have for loop or try catch is an exception, we will study this. While loop, switch, you can do control plus alt, control plus shift for converting into comments. Okay, alt plus shift plus r, change the name of the same variable elsewhere. Okay, these are just shortcuts for Eclipse only. There are different shortcuts for different IDE. This is for Eclipse if you want to use it. Okay, let's move on. Exceptional handling. What is exceptional handling? Okay, let's discuss this. Whenever you try to do some coding and somehow you get an error, or for example, let's say you divide a number 1 upon 0, what will this number give? It will give infinity, and infinity means it will give an exception error. It will just crash the system. But in order to prevent the system from crashing, we use exceptions. There are two types of exceptions. One is checked exception, which is checked in compile time. The other is unchecked exception, which this is what we are going to use. Unchecked exception, the one which occurs at the time of execution. The compiler will not check these exceptions at compile time. We can create our own exceptions. Okay, we can do manipulation in here. Unchecked exception. Okay, there are two types when throwing an error. One is the error, complete virtual machine error, output in out of memory error, stack overflow error. The other is exception. Okay, arithmetic exception. Okay, this is the exception would be arithmetic exception, or related to any mathematical calculation. Okay, so if we do 1 upon 0, it will give an error. Let me show you. If I just, let's say int a is equals to 1 upon 0, and if I sys out, if I print this, it will give an error. Exception in thread main Java, arithmetic exception by 0, division by 0. Okay, this is exception. So okay, since we know what is exception, let me tell you something. Now we know what is exception. There are three things you need to understand. One is try catch, when you're trying try catch final. The other is throw, you can throw exception yourself, and the other is throwable, we can say, or throws. Three things that we need to understand. Let's start with try catch, or let's just start from from here. Try is a keyword used to specify a block where we should place an exception code. It means we can use try block alone. The try block must be followed by either catch or final. Okay, trying something. Okay, let's say you're doing an experiment. If that experiment is successfully done, then hooray. But if that experiment I'm doing a chemical you can say explosive experiment. If that experiment explodes, then it will come into the catch block. It will catch an error used to handle the exception. Okay, try is something that you're just trying the code and you're just waiting for the code to give you an error. After giving the error, it will be redirected to catch block. Catch will just catch the error, it will handle it for itself. Okay, try, catch, and finally keyword is used to execute the necessary code of the program. It is executed whether an execution is handled or not. Whether there is an error or not, it will be executed. The code will be executed. Let me show you. Okay, trying a code. Inside here I'm going to try sys out 1/0. Okay, catch, if this block gives an error, it will handle this. Catch exception e, it will say I have catch the error, otherwise system would have crashed. Exception handling is so useful that it helps us to make sure that the system goes in normal flow. It prevents the system from crashing. Okay, it saves the system from crashing. It makes sure that the system goes in a normal flow without any disturbance. That's why I use exceptions. Okay, so if I just let me just finally whether the system will crash, whether the error will happen or not, I will still run. Doesn't matter whether the exception happens or not, it will still run. Finally run this. I have cached the error, otherwise system would have crashed, because this will give an arithmetic exception. Okay, but if I try to remove all of this, for example removing this, if I run this, it will give an error. So in order to prevent this crashing of the system, I will use try, I will use catch, and then I'm going to use this is optional. Finally, it's optional. It will just help you to run the code whether there will be error or not. Okay, so try, catch, and I've catched the error, otherwise system would have crashed. This is one thing. Try, catch. Now we need to understand about throw and throws. Okay, the throw keyword is used to throw an exception by yourself. You can throw the exception yourself. It's a custom error. You're creating your own, you're just identifying the error yourself, and you're just trying to manipulate it. For example, this is a method. If age is less than 80, I will just throw the error. I'm just throwing the error that access denied, you must be at least 18 years old. This is, you can say, throwing the error or creating your own error. Creating your own error, your own exception, you can say. Creating your own exception. Okay, you just throw this arithmetic exception, access denied, you must be at least 18 years old. Throw keyword, using the throw keyword. Okay, throw new arithmetic exception or throw new exception, like that. Let me show you. Let me remove all of this. Okay, for example, int age is 13. Okay, if age is less than 18, then throw new exception, you must be sharper and older. Okay, add throw declaration. Yeah, this is throw, throw new exception. You can throw like this. Throw and throws is, this is telling us that there could be an exception. Okay, this is telling us, okay, let me just clarify this. This is telling us that, hey, there might be an exception that could trigger. There might be an exception that could trigger or happen or could happen. Could happen. Okay, but in here I am creating my own exception. Like I'm just telling the computer, hey, this is the exception and this is the error, and you need to give this message if the age is less than 80, like that. Okay, so that's the difference. So let's see, run this. Yeah, you must be sharper and older, just throw the exception. So that's a difference. Okay, throws. In the above program we are getting compile time error because there's a chance of exception if the main thread is going to sleep, just given this. So throw illegal exception, like you guys get the idea why we use throws and throw. Okay, throws keyword is required only for checked exception, and usage of throws keyword for unchecked exception is meaning using for checked exception, you just to check when exception is thrown, the rest of the code in the try block is skipped and then run catch block. So this is exception handling. You're trying to handle the error just to make sure that the system doesn't crash and it goes in a normal flow. Okay, it prevents the system from crashing. So this is exception handling. And now finally we are coming to file processing. Okay, we need to understand about these things. One is serially, sequentially direct access, but this is talking about records. But before that I want to talk about text files. So there are two things: text file, which we are storing strings and all that, and binary file, which we are storing in bytes. How to create a record? Simple. Record is the same thing as, it's the same thing as creating an object, like class record, record student. You just create a class and then you just create an object. Record student r1 is equal to new record student, and there you go, just create you could just create a record. Or record a student r1 is equals to new record. Okay, this is, you just created the record, and after creating this record you can do save in the binary file. And how to do that we will come to that later, but for now I'm going to start with text file. So let's start. Whenever you need to start storing strings, you will use the file writer. Even though there are so many ways, you can either use the stream, output stream, you can use buffer, you can use file writer, but for now, for you guys sake, for in order to make it easy for you guys, use file writer. My recommendation is this. Okay, and now you can see here that there's an exception, there's a cache input output exception. There could be an exception, there could be an error that the file didn't open, or it didn't successfully saved, or it didn't successfully loaded. So that's why there is an exception for filing as well. So that's why exception handling is very important, just to make sure that the system doesn't crash at all. Okay, what's happening here? first of all, we create an object. File f is equals to new file. You're going to give the name of your text file. Text file name. Done. Now don't worry about this, it will be generated automatically. Once you're going to click, it will give you an option, generate try catch block. It will just generate for you, so don't worry. Then after creating this, file f is equals to new file, you're going to create file writer for writing a file, for creating a text file, creating a text file and opening it, and open it. Okay, creating a text file and open it. fw.write, hooray, it works. Don't worry about this. This is mean that it's given, it's just, it will come to the next line. Okay, instead of writing onto the same in the same line, this slash n means that it will jump to the next line and then it will write down again. fw.write, fw.write, fw.close. Okay, after writing it, you need to close. This is very important. So there you go, you have successfully created your file. Now you need to read it. So you're going to use file reader is equals to new file reader and putting this f, the file, okay, the file object in here. File reader fr is equals to new file reader. Which file you want to read? This file f, which means student.txt. Okay, after creating this object, now the thing here is that the file reader is storing it's in, you can say it's in encrypted, so it's in, you can say it's in bytes at some point. It has, because the file reader class is it inherits the output stream class. But like I just told you guys that there are so many ways to write to create a text file. You can use a buffer. Okay, buffers, you can use output stream, and you can use file writer. Okay, so I is equals to it, this is an integer, fr.read, it will be an integer. If it is -1, then it means that it reached the end of file, it reached the end of file. Okay, then after getting each one, you're just going to convert this in char, and it will generate the letters. Right now it's completely encoded. Okay, fr.close, and there you go. This is how you do, this is how you create, this is how you read. And as for append, let's see how we do append. Is at some point, if I wanted to do append, then I will just write down true. This means that yes, I want to append. Okay, putting this, it means that yes, you want to append. Otherwise false, or if you want, if you don't want to write, that's fine, it will just continue to create and write. Otherwise, if you put a boolean, the true means that yes, I want to append this, write and append. Okay, so that's how you do append, is how you create a file, that's how you read a file, text file. Now let's come to records. To store a record in a file, we create a binary file processed as a sequence of bytes. Okay, and in order to, let me just break you guys slowly. There you go, creating an array of object, creating an object by calling. Okay, this is how we are creating our record. So this is our class student record implements serializable. Okay, that's why I was teaching you guys interface, just to make sure you guys get the idea. So serializable is an interface. Okay, and you definitely need to do this in order to make it serializable, which means in order to Okay, yes, I need to just, why it is not deleting? Okay, it's done finally. So this is our class record. Okay, this is how you try to create a record. Okay, you just create a class and you just create lots of objects. You can say these objects would be your record, record 1, record 2, record 3. Implement serializable. This is really important in order for you to read objects into your file. Save the objects, because these records are objects. I need to read these. You need to save these objects into your file, into your binary file. That's why I need to put implement serializable binary file. Okay, these are the attributes. This is the constructor. These are setter and getters. Okay, after creating a class and put and do implement serializable, you came here, you just created lots of records. This is an array of objects. This is an array of objects. First you create an array of objects, number 1. Then in the second step you try to create, right now you can say that you just create an array of object without any memory. Then in here you create an object by calling the constructor. This is a constructor allocating memory to each object. Okay, creating an object in here. So there are two steps. One is creating an array of these objects, and then you just try to put a loop in order to allocate memory to each objects. Okay, creating objects by calling constructor and allocating memory. Okay, then you create a record of student 1, department software engineering, name Mohammed Musa, roll number 213804, semester 4, record 1, record 2, and then you just keep on going. After creating these 2 records, now it is time to save these records into a file. So how will I do it? Again, why? Such a sad thing. Erase all, Control X. Okay, it's worked. So now it is time to wait. It is time to save records into a file, or you can say write a record into a file, binary file. Okay, so it's binary file, not just any file, not just text file, it's binary file. So file output stream, you can use this file output stream. Yeah, you can use this file output stream as a, you can just create a text file for this. You can create object file as well, but for now right here we're going to use this for text, for the binary file saving objects. We're going to create a file .ser, serialize objects. This file is used for for storing objects. This file is used for storing objects, so always remember, use this. After creating this, then we're going to open another one, object output stream os is equal to new object output stream, and then you're just going to put this FOS in here. Okay, you're going to put FOS in here, and then you're going to use this to write objects. So R1 will go here, R1 index 2 will go here. Okay, file created successfully, file OS close, FOS close, save the objects in the file. Good. Catch, if anything happens, then this will run. Error happens, something went wrong, this will handle the exception, the error. Okay, now for just to give you just to do an experiment, I have purposely put this null, just to, you know, I've deleted the objects, because obviously if I'm going to retrieve them, then it wouldn't be a problem. Okay, that's why I've done this, just to make sure that my experiment works. Okay, coming down, now it's time to it is time to read objects from, or you can say read records from the file, read object from binary file. File input stream, in there it was output stream, object output stream, but in here it would be file input stream, object input stream. Okay, you're going to open this by using the same name, and then ois.read objects, read object, you just put, you're doing a cascading, just to make sure it converted to this class, and then you have saved this. And now you can see here that I've just shifted this, because whenever we try to say write objects, it is saved in serial form, in sequential. Okay, it is saved sequentially, sequentially. Okay, like you know, I stored R1 index 0, and then I stored R1 index 1. Right here I've written R1 index 2, or I think, okay, R1, okay, sorry, R1, this is R1, this is R2. Okay, but I have shifted R1 index 2, I'm reading this object and storing in R1 index 2. Okay, so I have just shifted this, and then this will be read, R1 index 2, it will be read into R1 index 1. Okay, just to give you an idea that whenever we try to read object from the binary file, it will always be read in sequentially. If I open the file and I write object into the file, it will be written sequentially, and if I open the file and try to read object from the file, it will be read sequentially, step by step. This is the reason why I've just shifted this. Is I could have written here like R index 1 or R1 index 2, but instead I just shifted this, just to give an idea that the objects are read sequentially. Okay, after reading this, it's stored in here, the memory is allocated in here, and then file close, and then finally I've just given I've just print this, and let me show you what is the result. So this is sequentially. Okay, what I have done here is sequentially, serially, sequentially. This is what we have done. Now in the next slide would be direct access, but for now I'm just showing you guys how to do serially, sequentially. Okay, so R1 was Muhammad Murtaza, software engineering. R1 of index 2 was cybersecurity, Arsal Javed. If I run this, you can see that record 1 is cybersecurity, even though record 1 was software engineering. I have just shifted this. So file created, file opened, loaded successfully, saved successfully. This is sequentially or serially saving or loading record from a file, from a binary file. Now let's come to the random access. Okay. Okay. So this is random access. What is meant by random access? Random access means that you are using hashing algorithm to, for example, you have a hashing table. Okay. This is a hash table. You have a bunch of records. You put one record in here. You put another record in here. You are saving the index, like this is 1, this is 4. These are hash values. Okay. And like you just randomly saving it, and you can randomly access them as well. So this is known as direct access of the records, not sequentially but direct access using hash value, using hashing as well. Okay. So what have I done here? I have created the record 1, record 2, and then I've just took hash value. I've done hashing in here, hashing, calculating the hash value. Okay. By it's something like h is equals to k mod 10, getting the hash value using this hash value as an index. Okay. Random access file is a class that is used for, we can say, for doing random access, for storing object in random access. So this is random access file. You have a file and it is storing the objects in randomly by the hash value. Okay. Randomly accessing, randomly saving them. So writer, first of all, I just open writer, and the name would be std record.data. Read write is a mode. Read write is a mode. Read write. Okay. Dot dat. In the previous class it would be dot ser, but in here it would be dot data. Okay. Because you're not actually in here, you're not actually storing object, but you're just storing the fields. Okay. You're storing fields, and this is the only way to save a record into a file when doing random access. Okay. That's why I've done like this. Instead of storing a whole record, a whole object into a file, which we do in .ser, we are storing field of the objects. Okay. So writer.seek, which means it is telling us where can we write this. So h1 multiplied by 50 means that supposing that the total number of records would be 50, total records would be 50 that we need to store. So you're just going to multiply by the total. H1 is 1 record, multiply by 50. Then you're going to write UTF st1.department, st1.name, st1.roll number, st1.semester. You're going to write it down. Okay. It's integer, string, adding record 2 now in different location. Writer.seek. Okay. This was hash 1, this was hash 2. And how did I calculate the hash using the roll number? This is a different roll number, this is a different roll number. Okay. After doing the same thing, and then I just close this. After I have created successfully, I have write it down the record into the file using random access successfully. So writer.close. Okay. Then I need to read from the file, from the binary file, using random access. And I've just created this just to test this. Okay. It's not really necessary. Or yeah, random access file reader is a new random access file. You just give the more read only, just give the name, reader.seek, the same thing, the same hash value h2. So now you are reading the record 2. Record 2 was, you are actually reading this record 2, cybersecurity Arsal Javed. Okay, h2 sd2, yeah, this one. So after putting this, you're going to just sequentially take these, reader dot read utf, reader dot read utf, department name, roll number, semester, reader dot close, and then you just print this, and there you go. This is how you do random access. There you go. Okay, so this is how you do random access. Cybersecurity SL Java 2038856. And congratulations, my dear audience, we have completed OOP finally. Now I will come to data structure in the next video. Thank you so much for watching, and if you guys need this PDF, do let me know. Thank you so much, because it's the end of it. We have successfully completed this whole everything. We discuss about class, access modifier, keyword, object, inheritance, polymorphism, interface, abstract, exception handling,